Hello everyone, welcome back to our revision journey. In today's video we'll be looking at a 2025 past paper, specifically mathematics paper 1, which was written by the internals last year in November. Alright, so without further ado, paper 1 mathematics has about 23 questions. Okay, so you're supposed to answer all these questions. It's different from paper 2, in which you're asked to choose some certain questions in section B. Okay, so for this video we'll first look at the first 10 questions that were brought in the last year's paper. Okay, then the other part of this video will be looking at the other 13 questions that were also brought in last year's paper. Alright, so without further ado, let's find out on how we were supposed to answer questions that were brought in last year's paper, starting from the first question up to the 10th question. Alright, so here we have the first question, and it reads, it's saying simplify 3 open brackets x plus 3 close brackets negative 2x open brackets x minus 1 close brackets. All right, now simply because they're asking us to simplify this equation, it is very simple. Excuse, we don't even need to waste time on such questions. They are very simple. Okay, so the first thing that we need to do here is to get rid of the brackets. So the coefficient, in this case it happens to be a 3, will multiply throughout, okay, so that we get rid of the brackets. Same applies here. The coefficient here, mind you, is negative 2x. So even here the negative 2x will multiply with what is in the brackets, and we'll have something like this. Okay, all right, so when we multiply 3 by x, we're having 3x plus 3 times 3, we're having 9. Then this side, when we say negative 2x times x, we're having negative 2x squared. Take note of that, because x times x is x squared. Then negative times negative, we have a positive. Then 2x times 1, which is 2x. Okay, and after that, when we reach at this stage, it's just a matter of grouping like terms. We can see that this 2x is the like term of 3x, so we can group these together. Okay, so in simple terms, we can just simply start with this one first. Okay, so we'll write negative 2x squared, this one which is here. So take note, when we are simplifying, please don't change the signs, okay, because here we don't have any equal sign to say no, it has crossed the equal sign, so it should change its sign. No, don't do that, please. Okay, when we are simplifying, we don't have any equal sign, so the signs should remain the same. Okay, this is one of the most mistakes that students make. Okay, what else do we have here? So we also have these two like terms, as I alluded. So we have 3x and 2x. These are like terms, so we group them together, and the positive 9 just comes here alone. So here we can add these. We can say these are like terms, so we can add them. We can say 3x plus 2x, and we have 5x. So our final answer in this case happens to be negative 2x squared plus 5x plus 9. From here, there is nothing that we can do, because all these now are unlike terms. Okay, take note, all these now happens to be unlike terms. Okay, so this is how simple it is. Okay, now let's go to the next question. All right, so the next question is saying we evaluate 4 to the power 1 over 2 or 4 to the power half times 4. Now, what is the first thing we're supposed to do here? Okay, so when you see such a question, the first thing that you're supposed to do is you get rid of this power. Okay, you get rid of this power. How do we get rid of this power? Mind you, this is a square. Okay, since it is a square, we can just introduce squares on both sides. What we do this side should also happen this side. So we'll first introduce a square this side and also a square this side, so that this square cancels with this power. Okay, mind you, this is a square. Why am I saying it's a square? Because we have 4 to the power 1 over 2. So it's a square. No wonder I'm introducing a square root this side. So when this square root cancels with this one, which means 4 will just remain alone here. Then what is this here? We don't have a power here. So we find the square root of 4. Take note. We find the square root of 4. So what is the square root of 4? The square root of 4 is 2. And we have something like this. So here what I've just done is that this square cancels with that power, and we have the 4 alone, which is there, multiplied by what is the square root of 4? The square root of 4 is 2. And when we multiply this 4 by 2, and we have our final answer as 8. These are very, very simple questions you'll find in paper 1. You don't even need to waste much of your time. Alright, let's proceed to the next question. So the next question is saying, factorize completely 3a minus c negative 3ab plus bc. Alright, now, when you see such a question and you're asked to factorize, one thing that I'll tell you is that just make sure that here you introduce brackets. Here, where there's 3x, you open your brackets here and here. Also, after this sign, any sign that you're going to have here, just introduce brackets here and here, so that you have two things that are grouped together, so that it looks something like this. This is what I mean, okay? So this side you introduce brackets, even the other side you do the same. Take note, this sign should just be alone, left alone here, okay? This is what should do. This is the simplest way to factorize completely such an equation. Alright, so now, after we group these two, okay, we group them like this, whereby we introduce the brackets. What's the next thing to do? We look for what is common on these first brackets, okay? We check for what is common. So what is common here? We can see that only 1 is common, okay? Because 1 can go into 3, and here also before c, there's a coefficient 1 here, or c is just 1. Okay, so there's one which is common this side. Okay, so when we factor out that, we still have the same thing. 1 into 3a is still 3a. 1 into negative c is still negative c. Then this side now, what is common this side? We can see that what is common this side is b. Okay, b is common. We can find b this side. We can also find b this side. Okay, so first of all, let's write this sign here. We put the sign in advance. Okay. Then now we say what is common here? B is common. Okay, so now when factorizing, so I had written a b here which was common. You open your brackets and you say b into b, that is 1. So what do you remain with? We only remain with 3a. You write your 3a there. Okay, then same applies. B into b, that is 1. Then you only remain with what? C, that is the c I had written there. So you can see that what is in the brackets now is common, or they are the same, including the signs. Take note, where did I get this negative? How did this positive change into a negative? I did this. I said what is negative times positive? Negative times positive, it is negative. No wonder this sign changed from positive to negative. Take note, when you are comparing these, what is in the brackets this side should be the exact thing what is this side also, including the signs. Take note of that, okay? Some students make a mistake by getting this actual sign, they put it here. No, you need to multiply this sign which is here and the sign which is inside in the brackets here. Okay, so I said negative by positive and it gave me back a negative. So no wonder here we're having this negative. So now, when you reach here now, it's just a matter of you factorize using the difference of two squares, whereby you open two brackets. These things are common. This one and this one, they're common, they're the same. Okay, even here there's a 1 which was common when we were factorizing this side. 1 was common and here b was common. You also group those together and you have something like this as your final answer. So what is in the brackets is common. This is what I've written here. And what else was common? What was I using to factor out? This side we said 1 was common. We were factoring out using 1 here. Okay, so this is the one which I've written here. Then this side, what were we using? We're using negative b. This is the negative b I've put here. Okay, this is how you factorize completely, as simple as this. Don't even waste your time. Okay, let's go to the next question and see on how I was supposed to answer it also. Alright, so let's look at this question. They're saying shed A complement, okay, A complement intersection, open brackets, B intersection C, close brackets, on the diagram in the space below. Okay, let's have this diagram first of all. Now, take note. When they say A complement, what do they mean? So when you just see this symbol here, when they say complement, which means they don't want that. They do not need that. Okay? They don't want that. So me, when I just see this, when I just see where they're saying A complement, which means wherever A is passing, they don't need that part. So we don't need this whole part. Okay? We don't need this whole part. That's what it means when they say A complement. We don't need this A part. We don't need it. Now, what do they need? They need B intersection C, the intersection set of B and C, where they're meeting or where they're sharing elements. Which part is that? That part is this one only. Take note of that. I'm not going where A is because they've told me to say we don't want A. By introducing this symbol here, they're saying A complement. Okay, this is very simple. This is just a free mark, I call it so. Okay, so what we need is the intersection part of B, the one which is here. Okay, so this is the part we are going to shade only. All right, let's shade that part. All right, like that. Okay, don't mind my shadings. Okay, so this is how you shade in mathematics. Okay, I've seen most students trying to shade as if they're painting. You don't do that. Okay, you just draw lines, simple lines like that. Okay, that is how you shade when you're dealing with sets. Don't make such a mistake of trying to shade as if you're painting. Okay. Alright, so this is the part that we need. So this part is the intersection part of B and C. You can see that my shadings are not going where A is because they've told me to say we don't need anything related to A. As simple as that. Alright, the next question. They're saying solve the equation x minus 1 to the power 2 minus 25 is equal to 0. Okay, wow, this is very, very interesting. Okay, so someone who can look at this question, when you just here they say is equal to 0, which means we're talking of quadratic equation. Okay, quadratic equation. All right, now how do we simply deal with such a question? When they say solve, it's like we are finding the value of x. The word solve means find the value. Okay, find the value. So in such a case here, we are looking for the value of x. Now, how do we do this first? Okay, so the first thing that we need to do here is to just get rid of this power for now. Okay, we just need to get rid of this power. How do we get rid of this power? Okay, I've just tried to rewrite it properly. Okay, so what have I done here? What I've done here is that I've said this negative 25 crosses the equal sign. It comes here where there's a 0, so that we remain with x minus 1 to the power 2. Okay, so it becomes very simple for us. So negative 25, when negative 25 crosses the equal sign, it becomes positive 25. Then now, how do we get rid of this power? We just introduce the square root on both sides. Okay, whereby this square will cancel with the power. Okay, because this is also a square. Okay, so this power will also cancel with the square. Then what is the square root of 25? This side you just find the square root of 25, which is 5, and you have something like this. So when this square cancels with the power, you only remain with x minus 1 is equal to, what is the square root of 25? The square root of 25 is what? 5. Now, since we're dealing with quadratic equations, we should have two answers. One answer should be in positive, one answer should be in negative. So I can rewrite this and say x should be equal to positive or negative 5 plus 1. Why am I saying 5 plus 1? This negative 1 has crossed the equal sign and it becomes a positive because we are solving for x. It's like we're just making x the subject of the formula when we reach here. Okay, we are making x the subject of the formula. So this -1 should go to this 5, which is here, this +5. Okay, so that we have like terms together. Okay, -1 and +5, they're like terms. So -1, when it crosses the equal sign, becomes +5. And why am I saying positive or negative? Because these are quadratic equations and we should have one positive answer and one negative answer. So we can first solve for the positive value. Okay, so we can first solve for the positive value here, whereby we say x is equal to 5 plus +1. Okay, so what I've done here, I've first tried to solve for the positive value. I want to find the positive value. Or we can also say, we also find for the negative value. So here I'm saying x is equal to -5. I'm now picking this negative. Okay, so -5 plus 1. We also want to know the negative value of x. Alright, so now here we can just simplify and say x is equal to 5 plus 1, which is 6. Then, or this side, for the negative value, we say these signs are different. When the signs are different, we subtract and maintain a sign from the bigger number. So in this case, our negative value is -4 for x. Okay, so the negative value for x is -4. So this is how someone needs to answer such a question. It is very simple and straightforward. Okay, mathematics, when you're just following the right principles, you always get things right. All right, let's go to the next question, which is question 6. Okay, all right, so we'll first do question 6, then go to question 7. All right, so question 6 reads, in the following diagram, P is the point 0,4, Q is the point -4, 0, and O is the origin. And we have this diagram here according to what they're trying to explain. Now the question is saying, find the equation of a straight line through O which is perpendicular to the line PQ. Alright, so now since we are finding a line which is perpendicular to PQ, which means PQ is using the first gradient. Okay, PQ is using the first gradient. Then for this other equation, we need to use the second gradient. So we first need to find the first gradient before we know the second gradient or gradient 2. So let's first find gradient 1. So finding gradient 1, we'll just use the standard formula, whereby we say gradient 1 is equal to y2 minus y1 divided by x2 minus x1. Now, where do I get these values? I'll get these values from these coordinates I've been given. Okay, we have some coordinates here. Okay, so here, this is x1, this is y1, this is x2, this is y2. As simple as that. So we'll just replace with the actual values. So y2, where is y2? Y2 is here, which is 0. No wonder here I've put a 0. Minus, what is y1? Y1 is the one which is here, which is +4. Divided by x2. Where is x2? x2 is here, which is -4. No wonder I'd put a -4 here. Minus, what is x1? x1 is right here, which is 0. No wonder I'd put a 0 here. And here you just simplify and say 0 minus 4, that is -4. Then -4 minus 0, which is still -4. And we simply divide there and we have our first gradient or gradient 1. So gradient 1 is equal to +1 because -4 into -4, that is +1. Alright, now if you look at the formula that we're supposed to use, we also need to know the second gradient. Okay, now I've simplified things for you here, whereby I've just said gradient 2 is equal to -1 over gradient 1. Where did I get this formula? This formula is coming from the standard principle, which states that the first gradient and the second gradient will always give us a product of -1. Okay, if you multiply gradient 1 times gradient 2, you should have -1. Now, I've just made gradient 2 the subject of the formula here by saying gradient 2 should be equal to -1 divided by gradient 1. So no wonder I was first finding gradient 1, because I cannot know gradient 2 if I don't know gradient 1. Okay, so let's find gradient 2. So gradient 2 is equal to the negative 1 comes like that. Then what is my gradient 1? The one I've found in the previous question is 1, positive 1. And we proceed and divide that. So gradient 2 is equal to negative 1. All right, now we can come back here and find the equation of the straight line. So now listen, one thing that you need to know here is that you can use two formulae to find the equation of a straight line. You can either use that other formula which states that y is equal to mx plus c. You can also use that formula, or alternatively you can use this formula. I prefer this formula because this one is direct. For the other one which states that y is equal to mx plus c, you need to find that constant number which is c. Okay, so that one is a bit longer. Okay, or some students even get confused when finding the constant number, but for this one is direct. Okay, but if you use the other one or this one, the answers will always be the same. So in this formula we're saying y is equal to y1 is equal to y minus y1 is equal to m2 open brackets x minus x1. So we just now need to replace the values. Now look at here. This is the point where some student missed it. They're saying find the equation of a straight line through O. Okay, since our point we're passing at O here, which means at O the coordinates for y and x are both 0. At O here, this is 0, 0 at this point. Okay, the value of x is 0 and the value of y is 0. Take note of that, please. Okay, this is the most mistake I've observed students make. Some of them, they'll get these actual values that they had given them in the question, whereby they say this is x1 and this is y1. No, look at here where they're saying find the equation of a straight line through O. So we are talking about this point which is here. And what are the x and y coordinates for this point which is at O? So the x and y coordinates are 0, 0. Okay, so my y here is 0, my y1, even my x1 is 0. Take note of that. Okay, so here when replacing, you only replace here where there's y1, m2 and x2. X and y, these will remain in the equation. Take note. Okay, so we have something like this now. So y is so y minus what is y1? At this point y1 is 0 is equal to what is my m2? My m2, the one I've found here, which is negative 1. Open brackets x minus what is my x1? My x1 at this point, which is it's also 0. So I'll have something like this now. So y is equal to negative x plus 0. Okay, when I simplify here, when you say negative 1 times x, it's negative x. Then negative times negative, that is positive 0. Take note of that. All right, so finally now we can simply say y plus x is equal to 0. When this negative x crosses the equals and comes this side, it becomes a positive. So you can say y plus x is equal to 0. Or in some other teachers will tell you to leave it like this, whereby you say y is equal to negative x. Okay, it's one and the same. This one and this are just one and the same. Okay, when negative x crosses the equals and comes this side, it becomes positive. What will remain here? Nothing. That's a 0 which is there. Okay, so this answer or this answer, they're both 100% correct. Okay, so this is what was expected for those students who wrote in 2025 the internals. This is what was expected for them. Okay, now let's go to question 7. Question 7 reads, they're saying, given that A is equal to this matrix, we have 1, negative 5, 2, 4, 3, and 7. Then B is equal to negative 2, 4. And C is equal to 1, 3. Then now they're saying, find the transpose of A. The transpose of A. So now listen. Under matrices, when they say transpose, just make sure that your rows become your columns. Okay, make sure that your rows becomes your columns. So here, this is just very simple. No need to stress or start thinking about on how you're going to solve this question. No, just make sure that your rows becomes your columns. So we can say the transpose of A is equal to, so you can set these rows have become the columns. Okay, so here we have 1 2 3, but now here they're like this 1 2 3. Okay, take note of that. Okay, then -5 4 and 7, they're like this. Okay, so this is very simple. Okay, so take note, mind you should also put brackets here, okay, to indicate that these are matrices. All right, now for B, they're saying we also find the matrix BC. BC, it's like they're saying we multiply B and C. Now, how do we multiply that? Okay, so let's first have them here. Okay, so here we say you multiply the rows and the columns. Okay, you multiply row by column. So here you just say -2 times 3, then 4 times 1. As simple as that. Okay, it's very simple. -2 times 3 plus 4 times 1. Okay, so this is some you have something like this. Okay, whereby you say -2 times 3. Okay, -2 times 3. Don't mind about this equal sign. Okay, don't mind about this equal sign, shouldn't be there. Okay, so you say -2 by 3. So here you're supposed to have plus. Okay, this one, which is an equal sign, supposed to be plus 4 times 1. Okay, I'm just doing row by column. So this -2 times 3, then plus 4 times 1. Okay, so here you're supposed to have plus, not this equal sign. All right, now after you multiply -2 times 3, you have -6. Plus, as I've said, this is a plus, so plus 4 by 1, which is a 4. Okay, then now you can add these, or you can say these signs are different. When the signs are different, you subtract and maintain a sign from the bigger number. So finally we have -2. So BC is equal to -2. All right, let's go to question 8. All right, so question 8 reads, if P is equal to 1 3 5 7, P union Q is equal to 1 2 3 4 5 6 7, and P intersection Q is equal to 5 7, list Q. All right, now here let's understand something very interesting here. Okay, so here they've given us the matrix P. We have the matrix P, okay, which is right here, and we also have P and Q combined. When they say union, they're saying everything in P and everything in Q is this. Take note of that. Okay, take note of that. This is very simple. It's just about understanding. Okay, when they say union, they're saying everything in P and everything in Q is this. Okay, but when they say intersection, they're saying what is found in P also being found in Q is this. Okay, please understand that. That is very important. Okay, that is very important. Okay, you should understand the difference between intersection and union. When they say union, they're saying what everything in P and everything in Q is this. Okay, but when they say intersection, they're saying what is being found in P also being found in Q is this. Okay, intersection means that. So if we talk of 5 is being found in P and also in Q. 7 is being found in P and also in Q. Now they're saying we list Q. Okay, we list Q. Let's start here. Okay, so to start with here, what I'll do is this. Since they've given me P, I know what P is, okay? And the only things that are found in P and in Q are 5 and 6. So, is 1 found in Q? No, it's not there, because the intersection has been already been given. That's saying the only things that are being found in both P and Q are 5 and 7. Okay, are 5 and 7. So 1 is not in Q. 1 is not in Q. Okay, 1 is only in P. So I won't write 1. Okay, what about 3? Is 3 being found in P? Okay, in Q. Sorry. Okay, is 3 being found in Q? Okay, they're saying the only things that are being found here is 5 and 7. Okay, so it's not there. Okay, now what is there? The first element that is there is 2. Okay, because you can set 2 is not in P, but here where they're saying everything in P and in Q is this. So if 2 is not here in P, if 2 is not here in P, and this is what is being found in everything P and Q, we have a 2 here. So 2 is only found in Q. Okay, 2 is only being found in what? In Q. It is not in P, because we don't have a 2 here in P. Okay, why am I using this? Because this is showing everything that is in P and everything that is in Q. Okay, so 3 we have already talked about 3. So 3 is found in Q, but what I mean in P, take note, 3 is being found in P, but what about in Q? In Q, they're saying there's no 3 there. Okay, so now what element is in Q? Okay, so the other element is 4. Okay, you can set even 4 is not there in P. So if it is not in P, it is then in what? In Q. Okay, take note of that. Then now let's go to 5. Okay, is 5 being found in P? Yes, it is being found in P, but take note here, they're saying P intersection Q. P intersection Q, there's 5. So 5 is in both P and Q. 5 is in both sets, which is P and Q. So we can write 5. Okay, why am I writing 5 even though it is in P? Because they've told me that P intersection Q, there's a 5. So 5, it means that 5 is both in P and in Q. Okay, then what about 6? Okay, 6 is not in P. 6 is not in P, and it is, but it is there in the union set. Okay, when they say P union Q, they're saying everything for P and Q. So 6 is in Q. Okay, so 6 is also in Q. Then finally 7. 7 is in set P, but the intersection set is saying even 7 is being shared. Okay, it's being shared. It is both in P and in Q. So this is how you answer such a question. Very simple and interesting. All right. Then now question 8b. They're saying a village banking cooperative for women declared a dividend at the end of a financial year. What was the dividend per share if Mrs. Spencer, who owned 1,025 shares, received 2,050 rands? Okay, now here this is very simple. You just need to find the formula. Okay, so the formula for finding dividend per share, we say dividend per share is equal to total dividend received divided by the number of shares. Okay, this is very simple. Okay, you just follow the formula. All right, now so dividend per share, what was the total dividend received? So the total dividend received was this one, which was here. Okay, take note of that. Okay, take note of that. All right, then what about the number of shares? The number of shares, that is 1,025. all right, so that when we divide that, we're going to have 2 rands. Okay, so the dividend per share was 2 rands. As simple as that. You don't even need to waste your time here. Okay, you just need to follow that simple formula. All right, now question 9. Question 9 reads, given that 7, 11, 15, 19 is an arithmetic progression, find the, so the first one they're saying we find the 10th term. Okay, we find the 10th term. All right, so due to space, I'll use some other space here, but we'll be coming back to the question. All right, so let's create some space. All right, so we are now going to first find the formula that we need to find the nth term. So we said the nth term is equal to first term. A is the first term, mind you. So first term plus open brackets n. N means number of terms. Okay, so n minus 1. Then d is the common difference. Okay, so you can see that we have the first term. Okay, we have the first term in our question. Okay, here the first term is 7. Okay, the first term is 7, and the number of terms they're talking about, they're saying we find the 10th term. Okay, so if we go back to our formula, what don't we have? The only thing that we don't have is the common difference. Okay, so let's first find the common difference. So the common difference is found by saying the second term minus the first term. Okay, the second term minus the first term. Now what is our second term? If we go back to the question, our second term is 11. So our second term is 11, then our first term is 7. So we just get these two and find the difference. Okay, so if we get those two, so we say our second term is 11, then our first term is 7, then we find the difference there. So the difference is 4. So the common difference is 4. That is what I'll be putting here where there's a D. Okay, this stands for the common difference. All right, so now we can rewrite our formula and say the 10th term is equal to, so you replace where there's n here, you say the 10th term. Okay, take note, mind you, this is very important right in the formula. It is very, very important. Okay, and in paper 1 you won't find any formula written for you. You need to know this formulae. Okay, so you say the 10th term is equal to, what is our first term? Our first term is 7. This is 7 I'd put here, plus number of terms. Which term am I finding? The 10th term, minus 1. Then the common difference is 4, the one we found here. All right, so we just simplify here and say the 10th term is equal to 7 plus, so here it looks so simple, but most students get it wrong because of how you multiply these numbers or how you deal with such figures here. Okay, so always make sure that you first get rid of what is in the brackets, so you first deal with what is in the brackets according to the laws of BODMAS. Take note of that. Always make sure that you first deal with what is in the brackets. So here I've said 10 minus 7, that should be a 9, not a 7. Take note, that should be a 9 here. Okay, a 9, not a 7. So 10 minus 1, that should be a 9, then 4, then 7 here. So this should be a 9. Take note of that. This should be a 9 because 10 minus 1, that is 9. All right, then now, so the 10th term is equal to, so when we multiply 4 times 9, the 9 which is supposed to be here, 4 times 9, you agree with me that 4 times 9 is 36. Okay, so 4 times the 9 which is supposed to be here, that is 36. Okay, so you first get rid of what is in the bracket. So you first deal with what is in the brackets nicely. Then you now say, what is 7 plus 36? 7 plus is 36, that is 43. So the 10th term is 43. So don't forget here to put a 9. Take note here, don't forget to put a 9 because 10 minus 1, that is a 9, not a 7. Okay, that is a 9. All right, now let's go to the next question. So the next question they're saying we find the sum of the first 12 terms. We find the sum of the first 12 terms. All right, now here again we just need to know the formula for finding the sum of the nth term. So the sum of the nth term is equal to number of terms divided by 2, open brackets 2 multiplied by the first term plus open brackets n, or number of terms minus 1 close brackets multiplied by the common difference. This formula you also need to know it. It will help you very, very much. All right, now the question is saying we find the sum of the first 12 terms. So where there's n, I'll replace with 12. So the sum of the first 12 terms will be equal to number of terms is 12 divided by 2. Open brackets 2 multiplied by, so where there's a, this is the first term, a is the first term, so the first term is 7 plus the number of terms we're talking about, the 12th term, minus 1, then the common difference is 4. All right, then we proceed and say the sum of the first 12 terms is equal to, so 2 into 12, that is 6. 2 into 12, that is 6. Then 2 multiplied by 7, that is 14. Plus 12 minus 1, that is 11. Then multiplied by the common difference, 4. Then now here, take note. So here you first need to multiply this 11 with the 4. Okay, you first multiply this side and add this, then multiply at last with the 6. Okay, Take note of that. That is very, very important. Okay, so once I multiply, so 4 multiplied by 11, that is 44, plus 14. Okay, then 14 plus 44, 14 plus 44, I'm having 56. You can see that the 6 should be multiplied at last because it is outside these brackets. Okay, it is outside these brackets, so it should be the last thing to multiply. Okay, don't first multiply then you start dealing with what is in the brackets. You will get the wrong answer. Okay, it is simple when you're just you know the formula and you're following the exact thing that I'm saying. Okay, most students get it wrong, whereby they'll first multiply this number which is outside here with what is in the brackets, then they start solving what is in the brackets. No. Okay, you first do with what is in the brackets. Okay, so 14 plus 44, that is 58. So 6 multiplied by 58, and we have 348. So the sum of the first 12 terms is 348. So if we add the first 12 terms from the 7 up to the 12th term, the answer should be 348. As simple as that. All right, let's go back to our questions. Okay, so this is how we're supposed to answer question 9. As simple as that. All right, now let's go to the last question, which is question 10. That's saying, so question 10a is saying, the probability that a learner will not miss the school bus on any particular day is 1/8. What is the probability that the learner will miss the bus on any particular day? All right, so here I'll give you a very, very simple secret here. So I'll say the probability of doing something and the probability of not doing something should always be equal to +1. Okay, if you add the probability of doing something and the probability of not doing something, the answer should always be +1. That's the thing. Okay, now this is what I've just said. So the probability, in this case, we are talking about the probability of the learner missing a school bus on a particular day or not missing the school bus on a particular day. So I'll say the probability of missing the school bus plus the probability of not missing should be equal to +1. Okay, no wonder I've said the probability of doing something and the probability of not doing something should always be equal to +1. So in such a case, we're talking about the probability of missing a school bus and the probability of not missing a school bus. All right, now what are we finding? They're saying, what is the probability that the learner will miss the bus on a particular day? So the probability of missing the school bus, that is what we are looking for. Okay, the probability of missing the school bus on a particular day, that is what we're looking for. But the probability of not missing has been given here. They're saying the probability that a learner will not miss the school bus on a particular day is 1/8. So we have this probability of not missing, okay, of not missing. So we can just evaluate that and say the probability of missing plus what is the probability of not missing, that is 1/8, should give us +1. And we can now say here, since we are looking for the probability of missing a school bus, so which means this +1/8 should cross the equal sign and come here where 1 is, and it becomes a negative. This is what I've done here. Okay, so +1/8 has crossed the equal sign and it has become -1/8. Now here, since we want to find the probability of missing the school bus, so we are now going to say we just balance here. We balance this one which is here. Okay, we balance it so that it also becomes a fraction by introducing a 1. Okay, why am I introducing a 1? Because when we are dealing with multiplication, 1 doesn't change anything, or division. Okay, 1 doesn't change anything when we're looking at division and multiplication. So you only put this one here to balance it so that it also becomes a fraction. Now after that, you just need to look for the common denominator. So we're going to say the probability of missing should be equal to, what is the common denominator here? The number where 1 and 8 can go into without leaving a remainder. That number is 8. This is the 8 I've put here. So 1 into 8 is 8. 1 into 8, that is 8. Okay, 1 into 8, that is what? 8. 8 times the one which is on top, which is still 8. This is the 8 I've written here. Take note, 1 into 8, it is 1. 8. 8 times 1 which is on top here, the answer is still 8. Okay, you first divide. We are saying 1, how many times can 1 go into 8? 1 can go into 8 times. Then 8 multiplied by the numerator, which is 1, so it becomes still 8. Then you get your negative, you put it here. Then 8 into 8, that is 1. 1 times 1 which is on top, which is again 1. Okay, this is very simple. Then now you finally say the probability of missing a school bus on a particular day will be 8 minus 1, which is 7, divided by what? 8. So this is our final answer. So the probability of a schoolboy or a learner missing a school bus on a particular day is 7 over 8. But the probability of not missing the school bus on a particular day is 1 over 8. All right. Then now, question 10b. That's saying two solids x and y, two similar solids x and y have surface area 5 centimeter squared and 20 centimeter squared respectively. If the volume of solid y is 200 centimeter cubic, calculate the volume of solid x. So here we'll just use ratios. Okay, so we're going to say x to y. What is the ratio for x? The ratio for x is 5 and the ratio for y is 20, like what they've said here. Okay, I'm just getting this information right here in the question. Now here we can reduce these ratios to their lowest term, whereby 5 can go into 5 and 5 can go into 20. So when we reduce these ratios to their lowest terms, we're going to have something like this. Okay, 5 into 5, that is 1, then 5 into 20, that is 4. Now why am I putting these squares? I'm putting these squares because this is area, and area, the units for area are centimeter squared. That is where I'm getting these squares. All right, then after that, now I can say, how do I get rid of the squares? I'll just introduce the square roots on both sides, so that this what is the square root for 1? That is still 1. Then what is the square root, or here we say 4 times 2, which is what? 8. Okay, so here now we have the ratio 1 to 8, or 1 over 8. 1 over 8 or 1 to 8, this is just one and the same. Now when you reach here, what do? When you reach here, what you do now, you say, since they've said if the volume of solid y is 200 centimeter cubic, okay, if the volume of solid y is 200 centimeter cubic, we're now calculating the volume of solid x. So we just multiply this ratio, or this fraction I've got, multiplied by the 200, so that I find for x. Okay, and I'll have something like this. This is what I mean. So 200 by the ratio, or the fraction I've found, and we have something like this. So the volume now will be equal to 25 centimeter cubic, because 200 times 1, which is 200, then 200 divided by 8 is 25. So we have 25 centimeter cubic. All right, so see you in the next video, where we'll be now looking at questions from question 11 up to 23. Thank you very much.